Shita, and today we are going to present a movie and music recommendation system, which is basically a content based recommendation system. Actually, there are three types of recommendation, which we are going to present you today is the content based. So, what is the content based means? It recommends the movie based on the similar results. So, based on the similar results of the selected movie, it will present the only the selected features of the recommendations movie. And there are other two also the recommendation systems, that are collaborative filtering and also the hybrid filtering. We'll come to that later. And as of this, this system will recommend a movie as well as a music. So, and the main abstract of this project is to like it as we like talk about the reality, more people they don't want to search each and every movie. Like if we are watching that Avatar movie, they need the same recommendations of that particular movie, so we can't search each and every movie in a row. So this system, this recommendation system, what it will do means, based that recommendations of that particular Avatar movie will be displayed, so the searching time of a client or a user will be reduced. And in today's world, it is more necessary, like we don't want to waste our time and go on searching. It's not like the customer, they don't want to that don't want that abstraction. So this recommendation will, what it does means, it relax and unwind, and with the overwhelming number of, it will take like more number of movies and musics. And today we have taken the movies and musics from the database, that is from the Kaggle. We have taken like the movie TMDD database, and from the Spotify we have taken the n number of musics and the movie collections from that. So basically it is employed with the content based filtering. So here we have included both music and the movies, so it will be more portable for the user to use it. And as I told earlier, it is very user friendly, and we have used the libraries called scikit-learn, NumPy, Pandas. We'll explain that about in the code as well. We have imported that, and this mainly what it does means, it will filters the entire database and it gives the user what we are particularly searching for. And as I told that, there are three types of recommendation system. One is content based, collaborative filtering, as well as the hybrid. As I told, content based it will give a similar result for the selected movie. But what does this collaborative means? It is more efficient than the content based, because it will give based on the user's highly recommendation. Because in YouTube, for example, nowadays the YouTube have developed a feature. It is developed using this collaborative. Earlier it was developed by the content based, where it will give only the similar results. But nowadays the YouTube has developed this collaborative. What it means, what we frequently go on searching the type of that videos we want to watch, and based on our interest it will record our details or the storage. And nowadays it is giving like what we see more interest, it will pop up in the home screen only. So it is nothing by the collaborative. It will give highly rated by the similar user, which is rated by us, and which we are going to see that. And the hybrid is nothing but it is a combination of both content and filtering based. As I told, like the database is from the TMDB database, which we have taken it from the movie database, and from the Spotify we have taken the music database. As I told, that movie recommendation is based on the user's interest. So this system is basically a software tool which will suggest the movie based on the person preference. And it is based on, we have used an algorithm called cosine similarity. This cosine similarity is nothing but it will take a similarity between the two vectors. What it means, like it is a vector where it will gives one which we have given is the one vector. The user selected is the one vector, and it will select the similar vectors which is adjacent to that vector, and it will take that and it will show that based on the user interest. Even the music recommendation is also it will suggest on the like same as it is from the movie recommendation. It will suggest the personal preferences, and it will predict it will predict then offer the appropriate songs based on the characteristics which I've heard previously. And the libraries and the technology which we have used here is the mainly the content based and Streamlit, Skykit and Pickle. Scikit Learn, which provides a major like features on the machine learning. It is for the machine learning tools for the extraction similarity calculation. Pickle is for serializing and deserializing the Python objects. And the proposed methodology is for the cosine similarity, which is mainly based on the similar and the adjacent vectors, and like feature selection through the visualization. These are some of the screen capture snapshots from the movie recommendation, where in the first slide we have recommended the movie, and based on that recommendation it has shown like many movies along with the posters, and music recommendation is same, that works as a movie. From next my friend will take forward. Thank you.
Here we this is the code for movie recommendation system. First, we have imported the NumPy and Pandas library. NumPy library is used for linear algebra calculations, whereas Pandas library is used for data processing and opening of CSV files. Here, TMDB 5000 movies and credits are opened using the pd.read CSV. This is the data sets, columns and rows, where budget indicates the budget of the movie, genders indicates the type of the movie, homepage is the homepage of the movie, ID is the TMDB ID of the movie, whereas keywords tells the type of the movie and the language of the movie, original title of the movie. This is the shape of the data set, that is 4803 rows and 20 columns. This is the credits data set, which is movie ID, title and cast and crew. Here we will merge the credits data set with movie data set, and we will get these columns. Here we will take the important columns of the movie and credits, that are movie ID, title, overview, genres and keywords, cast, crew, which are essential for the search of similar movies in the project. Here we will identify the missing and duplicated values, and we will remove those values. Here genres is in unformatted form. We will write a function to convert it into a formatted form. Using this function we will do that. After converting it, the data will look like this. This is a formatted one. Here keywords, cast and crew also in unformatted form. We will convert this in formatted ones using functions. using this function, we will convert the data into formatted one. After converting the data into formatted form, we will combine the important features of the movies into a tags, which is used for vectorization. Here we are combining this into a tag. After we combine those columns into tags, the data set will look like this. Here porter stemma function is used to remove the grammar words. After that, we will perform vectorization using cosine similarity. Cosine similarity is nothing but it will search for the similar nearest vector and will recommend that movie or that song to the users. Here pickle function is used to serialize the data and use it in other platforms like PyCharms, Visual Studios. Here we have used Streamlit for the web page creation. We will import the pickle files from the Jupyter notebook, and we have taken these IDs from TMDB website and Spotify to get the posters and song recommendations. After running it, this is the movie and music recommendation website. In movie recommendation, if we give the word avatar, it will suggest the movie similar to the avatar. These are the movies which are similar to the Avatar movie. This is music recommendation system. If we search for the song, it will recommend the songs similar to the Summer Romance. These are the recommended songs.
So this is about a project which would suggest both music and movie recommendation. It would be very useful for our which is portable and useful for our day-to-day users, which will be suggesting and time-saving, eco-friendly. So thank you so much.